Assalamu alaikum. In our regular classes, we discussed that we will cover few smaller topics in module 8. So in this video lecture, I am going to cover those smaller topics of module 8. Let us begin our discussion. The main discussion here is based on optimization of function. Throughout this course, we have dealt with several types of mathematical function. So in this module, we will look to find out the optimized value of the function, or in other words, we can say that we will discuss about some techniques through which we can locate the point where the function gives us the maximum value. To look for this optimized value of the function, we will cover two separate techniques. One is the golden section search, which is very much similar to the bisection method, and it is used to locate the maximum value of the function utilizing the golden ratio. So using this golden ratio, we will look to find the maximum value of any given function. Let's see how it works. For example, we have this function in the graph paper, and we will now try to look for the maximum value of the function. Apparently the graph is drawn here, we can easily locate where the maximum value is, but that might not be the case always. We might be given the equation of that function, and from there we need to find out the maximum value. So let's see how it works graphically. So we need to start with two reference values of x, just like the bisection method. One will be xl and one will be x upper. For this case, we have chosen the xl to be 0 and xu or x upper value to be 4. And within this range, we have to locate the maximum value. So now what needs to be done? Now we will apply the golden ratio, and after applying the golden ratio, there will be two new reference point on the graph. Okay, how we will apply this golden ratio? Let's see. So this is the golden ratio for this particular range, and for utilizing this, we will find two reference point on the graph as we have discussed. So those two new reference point would be x1, that will be xl plus d, the golden ratio. x2 is x upper minus d. So here we will find our x1, and here we will find our new reference point, that is x2. Once we have located these two new reference point, then we need to check the value of f of x1 and f of x2. Okay, if we check the value of f of x1 and f of x2, this is the implication in the graph paper. So here only two cases can appear. Either f of x1 can be greater than f of x2, or f of x1 can be less than f of x2, or in other words, f of x2 can be greater than f of x1. So in this example that we are looking at, the f of x2 is greater than f of x1. So if that happens, what to be done? Since f of x2 is greater than f of x1 here, the domain available right of the x1 to x upper will be eliminated. So this domain we will eliminate, and x1 will now be our new x upper, and then we have new range here. This is xl and this is x upper, and within this range we have to apply the same calculation and same method. We will find another two, applying golden ratio, we will find another two reference point, and then measuring the f of x1 and f of x2, we need to eliminate some part from the graph. Here we have another example where we have got the other case where f of x1 can be greater than f of x2. If this appears, in that case we have to eliminate the area or the domain that is left of x2 to xl. So this part will get eliminated, and correspondingly the x2 would become xl. Now this will be the new range, and within this new range we have to apply the golden ratio again. So that will give us new x1 and new x2, and from here we have to calculate the f of x1 and f of x2, then make the comparison, and depending on how the values of f of x1 and f of x2 pans out, we need to take a decision of eliminating either one side from the graph, and then we need to rerun the calculation again. In this way, after few iterations, we might get to see that we have come to a conclusion that we have found the maximum value of the given function. So that is one way of looking for the maximum value of a function. There is another way of locating the maximum value of a function, that is Newton's method, which is very similar to the root finding method named Newton-Raphson method. The concept here is that, let's say we have a function f of x at our hand, and if we can draw a tangent that goes through the maximum point of this graph and also that goes through the minimum point of the graph, and then we calculate the slope of those two tangents, the value of the slope of those two tangents will be 0. Which means if we can draw the graph of the first derivative of this function, which is f prime x, and we have named it g of x, in that case this function will have 0 crossing at those 2 points where f of x had maximum value or minimum value. So now look here, if we take g of x to be our reference function, and now we try to find out the roots of g of x using Newton-Raphson method, that will give us the points where f of x had maximum value or minimum value. So the logic of finding the maximum or minimum value of any given function here is that we need to take the first derivative of this function and name it as g of x, and then apply the Newton-Raphson method to find out the roots of that function of g of x. Or if we are not interested in naming this function as g of x, we can work with the given f of x. Then we need first derivative of f of x and second derivative of f of x, and then apply this formula to find out the roots of the function, and this will give us the points where the given function f of x might have the maximum or minimum value. These are the two techniques that we can apply to find the maximum value of any given graph, and once we know the maximum value of the graph, that means we have optimized the function. So that was the idea of these topics, that how we can find the maximum value of a function, or in other words, how we can optimize any given function. So thank you very much for your cooperation.